All right, this lecture is for Friday, August 22nd for um, the Principles of Biology class, and we're starting the second chapter, which has chemistry for biology students. And so we're going to describe some features of atoms, describe how atoms and electrons behave to form compounds. We'll talk about the chemical bonds and molecules that are in there, and we'll go through one molecule in particular, water. So chemistry is the study of matter. That's any solid, liquid, or gas. We're not going to be chemists. We're just kind of doing the minimum that we need to do so that we can understand biology. I know lots of people have a little phobia around chemistry, and chemistry is kind of abstract, and it's often when you say chemicals, people get excited because they think of toxins or poisons. But chemicals are any solid, liquid, or gas. Um, in chemistry, you have to do equations, you have to memorize formulas, you have word problems. We're not going to do any of that. We're going to just talk about some of the properties. Um, and biologists and chemists, I kind of make a joke that we don't get along, but we're scientists and we often study the same thing. Sometimes we even work together, but it's a slightly different approach that they have. We're not going to be chemists. We're not going to balance equations. We're just going to kind of describe the chemicals that we find in living organisms and cells. So, um, atoms are the smallest intact particles of elements. There are 92 naturally occurring different types of elements, each have their own unique type of atom. Um, all atoms have subatomic particles. The subatomic particles are the same in all atoms, but they vary in their numbers. Okay. All atoms will have a proton, at least one proton, but they may have more. Atoms may have neutrons, which are neutral particles that are in the center of the atom, kind of attached to the protons. And then there are electrons that are outside the center of the atom, outside of the nucleus, and that orbit around them. As I said, different elements, have different atoms that have different numbers of particles. The simplest atom is hydrogen, shown in the upper left of this chart. Hydrogen has one proton and usually no neutrons, and then one electron orbiting around that proton. So its atomic number is one because that's the number of protons it has. Helium then is the second element. It's on the upper left or upper right hand side. Hydrogen's on the upper right, helium's or upper left, helium's on the upper right. Helium has two protons and two neutrons and two electrons. The arrangement of electrons in helium gives it a um, stable arrangement where it doesn't interact, so it doesn't form chemical compounds. Hydrogen doesn't have that stable number, so it does. Some of the common atoms we'll deal with include carbon. Carbon always has six protons and six electrons when it's neutrally charged. Okay, but it can have various numbers of neutrons, 6, 7, or 8. Carbon 12 is the most stable isotope. Carbon 13 and carbon 14, you can find these, but they eventually will get rid of a neutron, and so they'll change into other atoms. Um, this is important. Isotopes, radioactive isotopes, can be used to date things because they decay at known rates very slowly. Hydrogen is, or excuse me, nitrogen 14 is converted to carbon 14 at a steady rate by cosmic rays. That that carbon 14 will revert back to nitrogen. Approximately 50% of it will revert back every 5,000 years. So you can measure the amount of carbon 14 in something, and it'll tell you how old something is. Okay, so I mentioned hydrogen has an unstable number of electrons in its orbiting around its proton, and helium has a stable number of electrons, and this determines whether they undergo chemical reactions. Any atom that doesn't have a stable number of electrons in its outer group of electrons will undergo a chemical reaction. Sometimes, if they have one electron in their outer grouping, they'll get rid of it. They'll donate it to another atom. And this atom, that once it's donated it, that atom then has lost a negative charge, and so it becomes a positively charged atom or an ion. The atom that picked up that extra electron then has picked up a negative charge, and it too is an ion, but it's a negative ion. Okay, and so opposite charges attract, and so these ions of sodium and chloride will then become attracted and form a chemical bond. And so chemical bonds are just where atoms lose or gain or share these outer electrons, which are called valence electrons, to get stable arrangements. In the case of Na, which is sodium, and Cl, which is chloride, this transfer of electrons causes an ionic bond. Okay, and so these things stay together because they're attracted to one another. Okay, another type of bond is a covalent bond. And in this case, atoms share electrons. So the electrons spend part of their time around one atom and part of their time around another atom. In nonpolar covalent bonds, they spend equal time around each atom. And so this close movement of electrons between atoms holds things together. It's a sharing of electrons. And you can have atoms can share a pair of electrons or sometimes two pairs of electrons with another atom. Sometimes the sharing is unequal, where the electron will spend more time near one end of the molecule, and that's referred to as a polar covalent bond. It's still shared, but it's not shared equally, and so this part of the molecule has a slight negative charge. So to summarize, covalent bonds are when atoms share two or more valence electrons. They do this so that they can satisfy this rule where they need stable number of atoms or electrons in their outer shell. The more electrons atoms share, the stronger the bond. And so there's many types of covalent bonds. Okay, hydrogen will form covalent bonds with other hydrogens, so it forms a gas like this. Oxygen will share two pair of electrons, and so it too forms a gas, but here it's an even stronger bond. And nitrogen will share three pair of electrons. So we see lots of different covalent bonding. Water, I've already showed water is one oxygen atom that shares electrons with two hydrogen atoms, and it shares them kind of unequally, so the atoms spend more time near the oxygen. So this makes the water kind of unusual. The oxygen part of the molecule is somewhat negative. The hydrogen parts are somewhat positive. And this causes the water molecules to line up, positive part next to negative part. And this kind of attraction, this weak attraction between them, is called a hydrogen bond. And this is what gives water its unusual properties, that it wants to be attracted to other water molecules, so it has surface tension and cohesion. It can also use these hydrogen bonds to dissolve substances. And so this is partly why water is so important. Life, we think one of the requirements for life is that there's liquid water. It's the single most kind of abundant chemical in living organisms, and these hydrogen bonds are really important. Water also stores a lot of heat because there's this interaction between different water molecules, and it stays liquid a very long time. It's hard to make it turn into a gas because the molecules want to stay together. And solid water is less dense than liquid water because of these bonds. And so when water does freeze, only the top freezes. Okay. And then water is a very good solvent. It can organize and dissolve molecules. Really important. Water has this high heat of vaporization. It does a lot of specific stuff. Whoops, let me go back here. Where was I? Okay, so high heat of vaporization. Solid water is less dense, good solvent. Water can form ions like hydrogen ions and hydroxide ions. So when we look for living organisms in on other planets, we the cartoon drawings and the movies show us, all these things. But the first really thing we look for is the chemistry of living organisms. And that chemistry is to look for water, to look for liquid water, to look for minerals that form in water like sulfates and carbonates, to look for erosion features that suggest water was on the planet. Um, when we go to other planets like Mars or the moons of Saturn like Titan or Enceladus, the first thing we're really doing is we're looking for water because it's such an important molecule for life. Okay, I'll stop there. We'll go into other types of molecules. I'll review chemical bonding on Wednesday, and we'll go from there. I'll open the second quiz soon, so you can start working on that second Moodle quiz.